We're now moving on to higher order derivatives, and a lot of the problems in this section will be asked to find the second derivative of the following functions are given to us. So let's go ahead and start the problems right away. So my first question is y equals to 1 over 2x minus 1. And I recommend for this problem that you should start by rewriting the problem as 2x minus 1 all to the power minus 1. And then you can take the first derivative. It's easier to take the first derivative if you write everything in terms of a power of negative 1. So if I take the first derivative, the negative 1 would come to the front. So negative 1, and then everything else would remain the same. It would be 2x minus 1, close the bracket, and then this power would go down by 1, so this would be negative 2. And then the chain rule states that I need to take the derivative of the inside guy, and that's going to be 2. Okay, and if I go ahead and just clean this up, 2 times negative 1, that derivative simplified would be negative 2, bracket 2x minus 1 all to the power negative 2. All right, so now that we've taken that first derivative, we can go ahead and find the second derivative by writing y double prime. And for the second derivative, this 2 would come to the front and multiply with the negative 2. So negative 2 times negative 2 is going to be 4, bracket 2x minus 1, close the bracket, and then you subtract 1 on the power, giving you negative 3. And then the chain rule states that you need to take the derivative of the inside guy, and that's going to be 2. And if you go ahead and just simplify that, 4 times 2 is going to be 8. And everything here that's being raised to the power of negative 3, that can just go on the denominator, and that would give you bracket 2x minus 1, close bracket to the power 3, and this is y double prime. So that's your answer for question number 1. That's the second derivative. Okay, let's go to question number 2. And for question number 2, I probably won't simplify this question to the simplest form. I will just go ahead and find the second derivative. And in order to find the second derivative, I need to take the first derivative first. So the 6 comes out in front, so it'll be 6. And then I'll get my green marker out here, and I will write the rest of the problem out, x squared minus 2x. And the power will be decreased by 1, so this will be power of 5. And then you need to take you need to follow the chain rule here, and the chain rule states that you need to take the derivative of the inside guy, which is 2x minus 2, close the bracket. Okay, so that's the first derivative right there, and then I will now take my second derivative. I need a little bit more space for my second derivative here. Let's go ahead and take the derivative of this expression right here in yellow. And this problem, there's a constant in front, so regarding that constant, I mean, you can just leave it alone. The constant doesn't do anything, so let's go ahead and take the derivative of that yellow expression. So the 5 will come out to the front. So it'd be 5 bracket x squared minus 2x to the power of 4. And then the chain rule states that you need to take the derivative of this inside guy, and that's going to be 2x minus 2. And then we just tag along the second term, which is going to be 2x minus 2. So this guy gets tagged along down there. And then the chain rule states, the product rule now states that you need to add. You need to add the first guy, which was technically this. This is the first guy, so that remains the same. That's going to be 6 bracket x squared minus 2x to the power 5. And then the product rule states that you need to take the derivative of your second term, which is going to be just 2, I guess. Yeah, just 2. So derivative of that guy is just 2. Okay, after that, we will do a little bit of simplifying here, and I mean, although I will take this as a final answer on a quiz or a test, you should definitely feel very comfortable with simplifying some of these steps here. So I will do that in this next step here. So in the beginning, 6 times 5 is going to be 30, and then this can remain x squared minus 2x to the power of 4. Now over here, I'm going to highlight the next parts here in yellow here. This part here and that part there, you can factor out a 2 on each of those terms. So that will be x minus 1, and then 2 times x minus 1. And then on the second term here, this 2 can times with the 12. Sorry, 2 can times with the 6, giving you 12. That would be 12 bracket x squared minus 2x to the power of 5. Okay, and then on my next step, I'm going to take my 2, and this 30, and multiply that together. So 30 times 4 is going to be 120. And then everything else can remain the same. X squared minus 2x to the power of 4, bracket. Now these guys right here in blue, since they're pretty much the same thing, I can write that as x minus 1 all to the power of 2 plus 12 bracket x squared minus 2x to the power of 5. Now there's definitely more factoring you can do. I mean, I see this term here in green and this term over here in green. You can definitely factor those out. And you can also factor out something from the 120 and the 12. I mean, that's more work to do, but I mean, I'll probably stop the question here just because I don't want to do any more simplifying, but you can definitely simplify more. I won't simplify these numbers right now, but you know, this simplifying the binomials here, I mean, you can definitely factor out an x squared minus 2x to the power of 4, and then what would be left would be 120 bracket x minus 1 squared plus 12 bracket x squared minus 2x. You can definitely factor that out. So here's that green part factored out. And if you want, you can continue to simplify the 120 and the 12 by taking out a common factor there, but it's just a lot of work, and I'm going to probably stop it from there. All right, let's move on to the next problems in this section here. All right, so a few more questions here. Find the derivative of this expression here, y equals to the square root of x squared plus 2. I guess for this problem here, it would probably be best to write the radical as a power, which we've been doing in a lot of problems in this chapter. So that's x squared plus 2 all to the power of 1/2. And then now let's go ahead and take the derivative. So the power rule states that the 1/2 comes in front, so 1/2. And that will be a negative 1/2 over there. And then we have x squared plus 2, close the bracket. And then the chain rule states that you need to take the derivative of this inside guy, which is going to be 2x. Okay, before we take the second derivative, let's go ahead and simplify the first derivative. That's like a general rule that you should always follow when taking the second derivative. Always simplify the first derivative. So this 2 and that 2 will cancel. And then this x here will remain on the numerator. And this part here in yellow, that will just go on the denominator as root x squared plus 2. Okay, so since you have an x on the numerator, and so you have an x on the numerator and x is on the denominator, I wouldn't rewrite this in terms of a power. Let's go ahead and just take the second derivative here. Okay, so we will not rewrite this. We will go ahead and just take the second derivative as is, and we will use the quotient rule to get started on this. So the quotient rule states that you write the denominator, I will write the denominator as is, and then you times that with the numerator, and the derivative of the numerator here is just 1, and minus the numerator, which is x, and then you take the derivative of the denominator, so this is really x squared plus 2 to the power of 1/2. So if you take the derivative of that, the 1/2 comes on front, so I will put a 1/2 in front, bracket x squared plus 2 to the power of negative 1/2. And then the chain rule states that you need to take the derivative of the inside guy, which is 2x. And then all of this will be divided by the denominator squared, so this will be x squared plus 2 all to the power of 2 there. Okay, so although that is a correct answer here, we should definitely try our best to simplify this. This part here in blue, I really can't simplify that, so I will leave that as x squared plus 2. And then on this part here in green, let's take a look at that. There's a lot of things happening there. So one thing I see right away is this 2 and that 2 cancel off. And this x times that x will give you an x squared. So let's put the x squared on the numerator. And then this part here that I'm trying to highlight in this darker color here, I mean, all that's being raised to the power of negative 1/2. So that can go on the denominator as root x squared plus 2, all divided by the bottom squared, and this 2 and this square root sign, they just cancel off, giving you just x squared plus 2. Okay, I mean, you can definitely simplify this more by, you can definitely simplify the numerator a bit more here, and I actually will stop here just because I could spend another few minutes doing the algebra here, but this is an acceptable answer in my course. Any version of the second derivative would count for full marks, so that's totally fine. This is enough for full marks. Okay, let's move on to the next question in the series here. X squared minus y squared equals to 4. Okay, so this one's slightly a different kind of problem here, but let's go ahead and take the derivative of this first guy, which is going to be 2x minus. Now the derivative of y squared, that's going to be 2y times y prime, and the derivative of 4 is going to be 0. Okay, so there's some implicit derivatives happening in this problem, and when you have an implicit derivative problem, you should always isolate for y prime. So I'm going to leave the 2x here, and then I'm going to move this entire term to the other side. And if I do that, the sign changes to positive, giving you 2y times y prime. And then we can divide both sides by 2y. Those terms cancel off, those cancel off, and then you're left with x over y equals to y prime. So I'm going to box that because this will be very important for the second derivative. Okay, let's go ahead and take the second derivative now. So if I take the second derivative, this is the first derivative, so the second derivative I would put a double prime. Sorry, that double prime didn't come out very nice, so y double prime equals to, now we will use the quotient rule here. So the quotient rule states that you take the derivative, you take the bottom, which is y, and you times it with the derivative of the numerator, and the derivative of x is just 1, minus the top, which is x, times the derivative of the bottom, which is y prime, all divided by the bottom squared, which is just y to the power of 2. Okay, so if I keep on simplifying here, this would be y minus xy prime over y squared. So this is y double prime. And the only thing that you could really do now is, here's y prime. You have to ask yourself, what does y prime equal to? Well, y prime equals to this guy right there. So if I keep on going here, this will be y minus x, open bracket, x over y, all divided by y squared. So this is your second derivative. Now, of course, you can keep on simplifying this guy, but I mean, I don't really want to spend a whole lot of time doing algebra here. So this right here is, a good enough answer. Just like the previous question, you can definitely, simplify the numerator and combine it with the denominator, and you do more simplifying. But once again, that's quite a bit of work. So this is my final answer for this particular problem. Okay, let's move on to question number 3. Now, I like question number 3 because for these kind of questions, you don't need to do like simplifying like I was trying to emphasize in the last few problems, but you just need to find the numerical value of the second derivative. So as long as you have the numerical value, then you're good enough. Okay, so let's go ahead and take the first derivative here, g prime of x. All right, so let's start off with the power rule. The 5 comes out in front, and then copy out the rest of this inner term here. And then the power decreases by 1, which will give me 4. And then the chain rule states that I need to take the derivative of that inside guy, which is going to be negative 4x, and then I'll close the bracket there. Okay, so that is the first derivative. And before we move on to the second derivative, it'd be very good just to kind of simplify the work in your first derivative. So now I have g prime of x equals to, well, 5 times negative 4x will be negative 20x times 3 minus 2x squared to the power of 4. Okay, so that's my first derivative simplified, and then I will go ahead and now take my second derivative. And the power rule states that this 4 comes out to the front, and 4 times negative 20 will be negative 80. Actually, sorry, I'm gonna go back a bit. Although I can do that, I I think it might be better for me to use the product rule here, and the product rule states that I need to take the derivative of the first term here, multiply with the second term. So the derivative of that first term there in green is going to be negative 20, and I'll put this in red. Close the bracket, and then I just times it with the second term, which is 3 minus 2x squared to the power of 4. And then the product rule states that I need a plus sign. And then I take the first term, which was now negative 20x, so I'll put a bracket here, negative 20x, and then I multiply it with the derivative of the second term, which is this guy right there, so that's going to be a power rule now, so the 4 would come out in front, 3 minus 2x squared to the power of 3, and then the chain rule states that I need to take the derivative of the inside guy, which would be negative 4x. Okay, so that is my second derivative there, and I will not simplify this question because the goal is you want to find the value of the second derivative at 1, so g double prime of 1. So what I recommend is you just plug in the value of 1 for all your x's, and then just compute the numerical values. So anytime you have an x, these x's I'm highlighting here in yellow, all those values will change to 1. So let's go ahead and just insert that number here. Now if you think about this, if I plug in 1 here, that's going to be 1. So this is really just 3 minus 2 all to the power of 4 plus. And if I plug in a 1 here, I get just a negative 20. And if I plug in a 1 here, that just gives me like 3 minus 2 to the power of 3. And if I plug in a 1 here, I just get negative 4. All right, so don't simplify anything. Just plug in the numerical values and things will work out very nicely. The negative 20 remains. And then, I mean, all of this right here, I mean, that's just 1, right? So now we can roll on with the rest of the problem here. That's going to be a negative 20 here. And all of this part right here, so I'm going to highlight this part here in green. All this in green is just 1, so you can just multiply the 4 and the negative 4, giving you negative 16. And yeah, then we just keep on going here. All right, so let's go ahead and just finish off the calculations here. Negative 20 times 1 is negative 20 plus, and we have 2 negatives here, so that'll give you a positive answer here, so that'll be 320. And negative 20 plus 320 will be positive 300 as a final answer there. Okay, so move on to example number 3 now.